All right, I'm back. We're on page 305 in the notes, and we know the product rule, we know the quotient rule, we know the power rule, sum and difference rule, constant multiple rule. We know the limit definition of the derivative. We know a lot of things. We know that derivatives tell us where a function is increasing and decreasing based on the sign of the derivative. We know that we can use that to sort of determine where there's a maximum or a minimum of the function. We're going to talk a lot more about that eventually. This page is mostly about practice. So let's see if we can do these, and we'll move on from there. So find y prime, so the derivative, for y equals some cubic thing over some linear thing, and simplify as much as possible. So depending on what I'm doing in life, my inclination might be to try to actually divide these before I find the derivative. I'm not going to do that because it says simplify as much as possible, and usually that just means dive in with the quotient rule. So that's what I'm going to do. I see a quotient, I'm going to use the quotient rule. So y prime, because that's what it asked for. I probably would have said dy dx if the problem hadn't said find y prime, but whatever. It's going to be, we have the bottom, the derivative of the top, minus the top. So this has to simplify as much as possible, but like, I don't know how much it's going to be possible. Over the derivative of the bottom, no, over what? Bottom derivative of the top minus top derivative of the bottom, all over the bottom squared. The advice that I usually give, which I never follow, is once you start the quotient rule, finish the quotient rule. Later in life, when you learn the chain rule, once you start the chain rule, finish the chain rule. Don't have side conversations, but I'm really bad at that. All over x plus 5 squared. So bad that I stopped in the middle of using the quotient rule to tell you never to stop in the middle of using the quotient rule. Bottom, derivative of the top, minus top, derivative of the bottom, all over the bottom squared. Okay, so I think this is okay. Simplify as much as possible. I'm not seeing any like terms really, so great question. All right, y prime is just algebra, I guess. 3x cubed plus 4x squared plus 15x squared plus 20x. I mean, maybe something magical will happen, but I doubt it. 2x squared plus 1. Okay, so don't forget to distribute that negative there. That's like the trickiest thing, I guess, that could happen there. All over x plus 5 squared. Okay, so y prime is, what do we got? 2x cubed, and then 4x squared, 5x, 19, so minus 2 is 17, x squared. I don't know if you can hear the birds, but they're having a day. Good for them. It's nice out. A lot of sun. Feels like spring. A good spring day. So what better thing to do than make videos here? All right, so should we check this on the calculator? Probably. Because if you do any problem, you should always check it on the calculator if that's available to you. So let's see. New something. I'm gonna do new problem. All right, we want the derivative with respect to x of x cubed plus 2x squared minus 1 over x plus 5. All right, 2x squared plus 17x squared. 2x, sorry, can't read. 2x cubed plus 17x squared plus 20x plus 1 over the quantity x plus 5 squared. Got it. All right, let's go back and see what the next problem is, because that's all that question really asks us to do. So, you know, why not? All right, new problem. Evaluate dy dx such that x equals 1. So that's the notation that you're going to see. You could sometimes see y prime of 1. That's more of a differential equations thing, and we have no idea what those are yet. But eventually you might see it. For y equals 3x plus 2 over x times the quantity x to the negative fifth plus 1, verify on your calculator. So notice it doesn't say find and simplify the derivative, then plug in 1. It says find dy dx such that x equals 1. So I'm not going to simplify, but what I am going to do is this stuff right here, I'm going to rewrite as 3x over x is 3, and then 2x to the negative first, because that's easier to deal with. So I'm going to use product rule because it's a product. So let's find the derivative. dy dx is, all right, first, 3 plus 2x to the negative first. Derivative of the second, negative 5x to the negative 6. Derivative of 1 is 0. Plus second, x to the negative fifth plus 1 derivative of the first. Derivative of 3 is 0, so it'll be minus 2x to the negative 2. Thankfully, this is going to be evaluated at 1. Almost any other value would just be terrible, such that x is 1 is 3 plus 2 is 5, and then negative 5 plus 2 and negative 2. So negative 25 minus 4, negative 29. All right, so let's verify the result on our calculator. Switch. I wish I just had a button. I could probably buy a thing that would let me do that. I don't know that I necessarily want to commit that much to it, but it might be useful. I mean, they definitely make things that are like hotkeys that you can just like press a button and it'll switch you. That would be amazing. I don't actually know if I could, I don't know. It's like, there are a lot of skills I could have acquired as I went through my journey in life, but I chose not to because I didn't really know where I would end up. And then we ended up here, and I kind of regret not getting some of those skills. X equals 1, negative 29. Remember, you should have done, I probably should have done, menu for 2, then at 1, and then I just need to type in the thing, but I didn't store it, so this is actually a worse choice in this particular case. That, since I already did it. If I hadn't already done it, that would have been the way to go. Whatever, regrets. All right, let's go back to the notes. So here we go. And the next problems are going to look a little weird. So people in my experience are afraid of these types of problems the first time they see them. No reason to be afraid. In fact, these problems are often easier because they use a lot of function notation. And because of that, you can't really end up doing the algebraic stuff, which means I'm not going to have to wade through like finding common denominators and all that stuff. It's just going to be substitution. So let's see. I'm going to need, so like we're told G prime, we're finding G prime. Let me start over. We're going to find G prime of 4, given that f of 4 is 3 and f prime of 4 is negative 5. So this must be enough information to do it. Look at part A. G of x is the square root of x, which I'm thinking of as x to the 1/2 because rational exponents far exceed radicals as far as calculus goes. So x to the 1/2 times f of x. That's a product, so I'm going to use product rule. So I'm just going to do first derivative of the second plus second derivative of the first. What is the derivative of f? So we have to keep that in mind. But the derivative of f, why can't I expand this? Whoa, okay. The derivative of f of x is like sort of by definition or by notation is f prime of x. So when I need the derivative of f of x, I'm just going to use f prime. All right, so let's do this. So g prime of x is going to be first, so x to the 1/2 times derivative of the second. Derivative of f of x is just f prime of x. Okay, plus second, which is just f of x. Derivative of the first, so I'm thinking of it as x to the 1/2, so it's 1/2 x to the negative 1/2. 1/2 x to the negative 1/2. Okay, so I think that's the derivative. There's nothing you can do with that, right? So that's why these are actually a little easier. We do know some values, so we're going to find g prime of 4 because that was the question. So square root of 4 is 2, f prime of 4. I'm a big fan of showing this step. If you recall from when we were doing like table stuff, I like to show this so that I can then go back and find my mistakes, which is why I always do it. And then 1/2 times 1/2 is 1/4. Okay, and then g prime of 4 is 2. F prime of 4 is negative 5. So negative 5 plus f of 4 is 3 times 1/4. Okay, negative 10 plus 3/4, which is like something. G prime of 4. Negative 40 plus 7 is negative 33 over 4. G prime of 4, negative 33 over 4. So it's probably, my 3s, man, are a struggle. You seen that? 3. I gotta like get one of those books that has like the lines for like little kids when they're just learning, like make sure I can do this. I don't know. You could use decimals. I'm just like not, for whatever reason, I'm not that big a fan of decimals. I feel like a lot of things are easier when they're just like fractions. Fractions are just like a little cleaner. All right, I see a quotient, so it feels like a quotient rule problem. Bottom, derivative of the top, minus top, derivative of the bottom. So even though it's times 1, I usually write it because then you're trying to like make sure that the form matches what you expect. So when you go back and check, you can do it. All right, so g prime of 4 is going to be 4 f prime of 4 minus f of 4 times 1. I'm not going to write it there. Over 4 squared, which is 16. Excuse me. So g prime of 4 is 4. F prime is negative 5 minus f of 4 is 3 over 16, which is negative 23 over 16. Okay. We don't really know anything about the function of g, whatever g of x is, in either case, but we do know the slope of the line tangent to the curves. There are 2 different curves at x equals 4. Could we write the tangent lines? We know f of 4. Yeah, if we wanted to, we could write the equation of the tangent lines. Maybe I'll do that here. So it's not asked for, so different color, I guess. G of 4 in this particular case is going to be 2 times what's f of 4 is 3 is 6. So the tangent line, because this is a really common question, would be like y minus 6, negative 33/4, x minus 4. For this one, g of 4 is going to be f of 4 is 3 over 4. So then the tangent line, so this was not a part of the question, but you should always be thinking of these things, like what more could I be asked to do? Writing a tangent line is always something you could be asked to do. 3/4, negative 23/16, x minus 4. All right, so I'm gonna stop this video here, come back in another video and just, keep going. We're making a lot of progress. We're learning a lot of things. We're using those things, trying to think of extensions, like how could I use things that I already know to do new things or the same thing over again? Who knows? Anyway, I'm gonna stop this here. I'll see you in the next one. I hope you're finding these helpful, and yeah, that's it.